Okay, so I'm going to be talking about a bit of an unusual topic, and that's object-oriented software design patterns in JavaScript. What is a design pattern? Well, my definition is it's a reusable solution to some kind of a class of similar issues. And you can also say it's a blank template you can apply to a sort of problem. And of course, we have patterns, but we also have something called antipatterns, which is something that you apply often to some situations, and that's bad. And for example, in JS, we have sticking things to the prototype of objects, especially objects you don't own, like adding functions to array, and somebody else uses this array, and it doesn't work, it breaks. And that's an antipattern. What are the good parts of patterns? Well, a lot of people have used them, and we know they work. They're quite generic, most of them, and we can use them on problems which are similar but not at all the same. And one big thing about patterns is that they offer us a common vocabulary. You can go talk with your colleague who works in, I don't know, in Rails, and you can say, well, okay, I have to solve this problem, and I want to use this pattern. And most branches of programming know this vocabulary, so they'll understand you. And of course, we have a mostly clean and recognizable interface, which ties into the communication thing. People will know what to expect with the name of pattern in most cases. Now, of course, we also have the bad parts, and that's a lot of people misuse patterns. This often happens when people learn about new patterns, and when you have a hammer, everything looks like a nail, and they use this pattern in everything they can, and this is, of course, bad. Another issue is over-engineering. Of course, you can solve some problems using a design pattern, but you don't have to, especially not in a language like JavaScript, which is not a single paradigm language. We have functional solutions, and we can just use imperative solutions instead of object-oriented solutions. And of course, as I said, you might not need them for some languages. So I like to offer some rules of thumb for this. In most cases, unless you're solving a problem you know well, you don't want to look at it and say, okay, I'll use a pattern and I'll solve it with this pattern. Instead, start coding, and you might see a pattern appearing. That's okay, and then just wrap it up. Again, as I said, if you can use a pattern, that doesn't mean you have to. There's often a more elegant solution. And finally, I hope everyone gets this. If you don't understand the pattern, don't use it. Read more about it and educate yourself. So in JS, we actually have patterns in everyday use. JS is not a class-based language, but we do have objects, so some patterns still apply. And quite a lot of popular libraries, including jQuery, everyone knows jQuery, use quite a few patterns. And because JavaScript is prototype-based, not class-based, some of them are a bit different. And of course, because it's not a pure object-oriented language. So now that I've covered the basics of pattern and what I think about patterns, I'd like to talk about a few concrete examples, which I picked because they are used in some libraries, or you might want to use them yourself. I'll just cover the broad strokes. I don't expect anyone to understand all I'm going to talk about, but you'll get a decent overview of the subject at hand. We have a classification of patterns in most literature, and most of it comes from the old Gango 4 design patterns book. So we have creational patterns, and they, as the name implies, they create an object. We have structural patterns, which modify or wrap or proxy an object in some way. And we have behavioral patterns, which take an object and modify how it behaves. And in newer classification, we have concurrency patterns, but of course, JS is a single-threaded language if you ignore service workers, so we're not going to be talking about those. One of the most basic creational patterns is a singleton. And a singleton is a simple pattern which guarantees that you have only one instance of some object in your code. And it's typically done using something called lazy initialisation, which means you don't create an object until you need it, and when you need it, you always return the same one. So I wrote a simple-ish example. We have a provider which knows it has a class and it knows how to provide it. And it wraps the class, so the only way you can get an instance is using the constructor for the instance. And this is how you use it in most cases. So let's talk about, as I said, it ensures only one instance is constructed, and we have always initialisation because we don't have it until we need it for the first time. So what's good about this? The good part is that it's good if we actually need one instance. For example, not so common in JS, but for example, if we have access to a database or an API or something, and we don't need 50 instances of it, we need just one instance, especially if it's expensive to make it. But of course, the bad parts are that it's sort of a global object. We just print it up, and nobody likes global objects nowadays. Another issue is if we have a singleton, it basically knows how to make itself and what it does. And we have something called single responsibility principle, which says an object should just do one thing. And this sort of breaks it, the principle. And of course, another issue is that we have global state, which is especially dangerous if we mutate it. And this is very hard to test because you might have 50 items using the same global service to exchange data, and it's very hard to cover real world situations in your tests. And one solution to this is inversion of control, usually through dependency injection. So what is dependency injection? It's a principle, or rather a set of tools that externalizes this dependency measure for you. So you say you need something, and there's an external system which handles this for you. And there are many ways to do this in a wide variety of programming languages, but in JS we usually do it sort of via some dependency system. This is not full dependency injection because we still have some logic attached to it, but I won't go into it. It could be a whole new presentation. And we have some frameworks like Angular, which actually analyze the text of the function and use that to instantiate our object. So that's it about the singleton. Another creational pattern, which is quite common in the development world, is the factory. What the factory does is it simplifies the creation of objects for you. It usually creates different objects from the same, let's call it a class of objects. And it uses the same interface for different objects. So I won't go into a definition, but let's have an example of it. For example, you might want to have a form which has some sort of a theme. And you say, okay, it's in the iOS style and it's light gray and we tie it to some model for the data. And then we make a form and we make an input and we make a submit. And all this looks the same, but of course the underlying code is quite different. And that's basically the point of it. We give it a type and some options and it makes a class. And we give it a different type and the same options, and it makes a different class. And it makes the job of creating classes easier from the outside as a black box. So yeah, as a programmer, it simplifies things. And sometimes it can decouple logic, because when you're using a factory, you have to know a lot less about the object you're making than when you're making it manually. As a user, not as the author of the library, of course. However, it introduces overhead, it makes code less efficient, and of course it makes testing more difficult because you have more branches to cover. And in client code, in apps, it's usually an overkill. You probably don't need complex factories in your code, it's more framework level stuff. Of course, not always, but in most cases. And the third creational pattern I'll be talking about, and my favorite one of the lot, is the builder. So what does a builder do? It also abstracts over creation, makes it more simple. And you start with a basic instance. For example, you start with a model which just has some text. And then you use meta chaining to attach some properties to it. And it's very popular in UI frameworks, in jQuery, and in other cases. So this is an example. We make a prompt, and then we make it full screen. And we add a confirm button, and a cancel button, and a close button. We don't have an overlay, and we add some handlers. And this is very readable. And it replaces something called a telescopic constructor. Does anyone know what this is, a telescopic constructor? It's basically when you have a constructor which takes like 20 parameters. And that's where it gets the name from. And it's great for designing widgets, for example, prompts, models, and so on. And you've probably seen code like this in unit testing frameworks, so like should.js or Jasmine and so on, because you can just change stuff and get some functionality based on some default. And it's very easy to read, as I said. Of course, again, it's harder to test because you have a lot of code branches to cover. Maybe the user did define this, and maybe they didn't, and maybe they defined this option and maybe not, and so on. And again, this is a bit more common than the factory, but it's not that common in user code. So it's good to know, but you probably won't be writing one so often. So that's it about the creational patterns. Let's talk about the structural patterns which modify or wrap an object. And one quite popular one in JS, again found in jQuery, is called a composite. And what a composite does is it takes a function or an operation or something and it applies it on something. That something can be a single object or a structure. And of course, the structure is most often an array, but it doesn't have to be. And the common example of this is in jQuery. Most operations work regardless if you select a single element or many elements. You, as a programmer, don't have to worry about this in most cases. It just works. And this is great for usability. And the only complaint I can think about is that it makes code a bit less clear because you don't actually know how many objects you selected. But I don't think that's really an issue. Another component from the same vein, from the structural patterns, is the designer pattern. Now, the decorator pattern. Now, what the decorator does is it, as the name implies, takes an object and decorates it with additional functionality. It makes it more powerful. And it is given an object and never makes its own instance. So you take an object and you wrap it in the decorator. And you can also do this by subclassing or in some other ways, but this is often the cleaner way. And in JS, because decorators often have to know a bit about the structure of the object, we have to use something called duck typing. Now, for those of you who don't know, duck typing means you use some properties of the object to guess its type. For example, you say, okay, this object is of class X if it has method Y, then we can pretend it's of class X, because we don't actually have strong typing. And this is a simple example. We have a resource which knows how to save itself and load itself and all the CRUD operations. And then we say, okay, we know how to log it when it does its operations. And we can take this resource and we can say, okay, let's wrap it in a caching decorator. And now it knows how to cache itself. And we have a cache resource. And okay, now let's wrap it in another decorator. Let's call it a logging decorator, like the one we saw in the last slide. And now we have a resource which can do everything a resource can do, but it can also do logging and it can also do caching. And this is great because it's very flexible and we can do it as much as we want. And we don't have to have a million subclasses for slight variations in behavior. On the other hand, it's a bit complex sometimes if you have a lot of them to keep everything in your head, what something does. And if you use multiple instances in the same scope, some less and some more decorated, you have a lot of variables which are similar and that might be hard to name and manage. But it's not that bad. It's actually a useful pattern. And of course, it's less efficient because you wrap stuff. And finally, the last structural pattern I'll be talking about is the facade. It does something quite simple, actually. It takes something very complicated and it makes it simple for you. It hides away the complexity. And again, it's big in, amongst other things, in jQuery. And all of these are facades. They look very simple from the outside, but they have a lot of code on the inside. They make the job of whatever they do much easier. And as I said, much nicer interface, very clean from the outside. If you don't care how it works, it just works. of course, performance hit, because you complicate stuff. In most cases, you cover different browsers or different behaviors, and in most cases, you actually don't need to check all of those. You know what you're doing. But this, again, makes it simpler. And again, in most cases and in applications, you won't be writing those, you'll only be using them. But still nice to know. And finally, onto the last class of patterns, onto the behavioral patterns. So I'll be talking first about the observer pattern. So what does the observer pattern do? It has some sort of a message author, which does some action. And then you have other objects called observers, which attach themselves to the object, and they wait to be notified of it. For example, you might have, I don't know, an object which displays a form, and it knows when it's clicked on. And when it's clicked on, it notifies all its observers. And so the only thing the observer has to know is it has to know how to be attached to something. It doesn't even have to do it itself. It just has to be attached. And it has to know how to react to a notification. And the author has to know a bit about the observer structure, because they have to know how to notify them. And of course, JS, we use duck typing again. And we have something similar, which I'll also mention, which is called pub/sub, or publisher subscriber, which is slightly different because the observers don't attach themselves to the object, the author, but they use a shared bus. And we'll have that in a few slides, so I'll talk a bit more about it. So this is an example author. It knows how to receive observers, and it knows how to remove them. And when something happens, it can notify them. And they're notified, and everyone's happy. And the observer has to know how to be notified. And this is basically how it works. You have an observer, it's attached by itself or by some other object, and then it receives messages, one or more or none, and it reacts to them. Now, pub/sub works like this, basically. You have a shared channel, some sort of an event bus, and you have some number of subscribers, and they listen to some event. In this case, it's message_x. And then 0 or 1 or more publishers, they say, okay, I'm publishing message_x. And then everyone who's listening to message_x reacts to it. So it decouples it even more. This is a recap. And it's very good for decoupling because they have to know less about the logic. They have to know how to notify each other. This is especially true for pub/sub, because all they have to know is how to listen or publish to a channel. And this is very big in many frameworks. And you have it even in Backbone, you have it in Angular, you have it in some format even in the state management libraries. Of course, the issue is, especially with pub/sub, that they might not be aware of each other. For example, you could be sending critical messages and there's nobody listening on the other side. This, of course, makes it harder to test because you can't guarantee, in most cases, the presence or absence of publishers and of listeners. And finally, the last pattern I'll be covering today is a very useful one called a mixin. So what is a mixin? It's a bundle of some common functionality, like you might find in a util library. But instead of using it directly, you extend other objects with it. It's, again, an alternative to subclassing or utility classes or even decorating in some cases. And in many languages, it's built in. It's usually called either a mixin or a trait or something similar. So how does it work? So let's say we have a rectangle and we have a path, and both are drawable. They know how to draw themselves. And we say, okay, we have a animated mixin, which knows how to do some basic animations. And we say, okay, because we know we have a drawable, we can just attach this functionality to our objects, and bam, they know how to do this behavior. And we can also do this, for example, for authorization. We can replace some middleware with this, and so on. So it's like util libraries, it's excellent against duplication. It's good for modelization of code because if something is not completely shared, you can just take it out and go it in where needed. And it's, in most cases, very testable, and of course, very easy to mock, because it's a separate bundle of functionality, and you don't have to worry about it being there, you can just mock it. Now, the only issue I can think of is that in most cases, you won't attach this to a single object instance, you attach it to the object prototype. And then you have prototype pollution, and in modern ES6, you actually lose access to super. You cannot call the method you might be overriding, or in the go of the prototype chain. There are ways to avoid this, but I won't go into them. So that's it for the specific examples. Now, I want to say, so all of these patterns are good. We have them, they're useful, we can use them, we can talk about them, but not everything is worth a pattern. You don't have to limit yourself to the object-oriented pattern in JavaScript because, as I said, it's not a purely object-oriented language. And again, don't make everything an object. This is JavaScript, which is slightly different to Java. So we're good.
Just a little bit.
Yeah, just a tiny bit. So yeah, know them. You have to know patterns. Maybe not because you have to use them, but because you work with other programmers, and most programmers know at least a little bit about patterns. You can communicate with them, and it's expected to know you know them. At least if you're consider yourself an engineer, not just a code monkey. And it's very important again when not to use them. So I have some resources for you. This is a book about patterns to JS in particular. This is about design patterns in a bit more detail, but applied to C++. And this is a criticism of patterns. And that's it. Here's my email if you want to contact me. I don't have a Twitter account, so none of that. And do you have any questions? So questions? No? Yeah?
In the PubSub or the observer pattern, a concrete implementation in JavaScript, does it use what event emitters and event listeners, or does it have a polling function that checks for listening?
So the question was, in a concrete implementation of PubSub in JS, does it use event listeners and emitters or polling or whatever? Well, it depends, because in some cases you're talking about DOM events. In some cases you might be using just simple, you take something, you have an object which says what subscribe to it, and you just iterate and call it. It all depends on the use case. It could be very simple or very complicated. But actually a nice example is you have the annotated source for the backbone framework, and they have an event bus as an abstract thing, and you can look at it, and it's quite clearly implemented. I suggest you do if you're interested. Yeah, you had a question?
Yes. Since you're an experienced JavaScript developer, Luka Skukan,
yeah.
Can you actually tell me in the past year what patterns have you used, in what cases, and why?
Okay, I used Mixin just yesterday, for example, because I had to abstract some behavior from a shared resource to separate resources. I use, especially when working with UI stuff, I use Builder a lot. Sometimes PubSub, but most frameworks provide it for me, so I don't implement it. And of course, every time I use something like jQuery or even my own library to do similar things, I use things like composites and so on. Basically everything on this list except maybe a factory I've used in the last few months. Oh, and no, actually I've used a singleton. Yeah. Any more questions? No? Okay.